our second tutorial. In previous tutorial we have covered that how system Verilog includes new elements in it. If you are aware about Verilog, then this tutorial will helpful to you. In this tutorial we will cover data types of system Verilog. Let us start from the very basic of system Verilog, that is architecture of system Verilog. This works on layered test bench that you can refer from any book. The book that I am following is System Verilog for Verification by Sphere. Now we are on chapter number 1, Architecture of System Verilog and Data Types. This, we are on a topic number 1.10.4. Page number 19. This is a DUT, design under test, followed by driver, agent and generator. The very first layer, you can see scenario layer is in this is a complete one, page number 20. Like, if you know the how to write a test bench in Verilog only, that includes a top module that wrap it inside a DUT by instantiating DUT inside a top module or in a test bench. But in system Verilog there is different. Here you have not a top module, you will have a program block that will generate a test. This thing. What is a generator? Here in system Verilog we work on random theory. We have to create test vectors using a class of generator. We will work on this theory separately, some syntax how to create a test vector randomly, then followed by an agent and a driver. This transfer of test vector from generator to DUT to scoreboard is done with the help of a mailbox, that is a separate chapter, followed by scoreboard and checker. Now see, you are supplying your test vector created randomly inside a class named as a generator and transferred to DUT with the help of agent and driver with the help of mailboxes or semaphores. DUT, after getting some input, gives some response with respect to that randomly created test vector. Okay, now that response is captured by monitor. Now we have to compare that output of DUT with respect to that randomly created test vector with some expected output. Now how that expected output come from, how that expected output is calculated. That same test vector we are going to feed to scoreboard. Now what scoreboard includes? Scoreboard feed some input to the scoreboard. Now what scoreboard includes? Scoreboard includes the same design inside it, that is in DUT, but if DUT could be in VHDL, in Verilog and system Verilog, and similarly scoreboard, in scoreboard test engineer is going to write the same design, same functionality, that could be in C, C++ or VHDL or Verilog, all that. For example, you are doing A plus B. How will you write that thing in VHDL or in Verilog? There in VHDL there is some entity followed by architecture, and inside architecture you write some A XOR B, and similarly for carry if it is a half adder. And what about in Verilog? You will write assign some, not this, A XOR B. Okay. followed by some module and module, all that. DUT has to be in such a designed in such a way that has to be synthesizability, that is to be synthesizable. That is designed by design engineer. But the code written in the scoreboard has nothing to do with synthesizability. That should not be synthesizable. You have to just give some input and you have some output that you're going to compare with DUT output. Okay. On the based upon the comparison, you are going to say that that your DUT is faulty or without any fault. Now let us suppose you are having some fault in DUT. That means your scoreboard output is not matching with your DUT output. What will you do in that scenario? How you come to know where is the actually an error in whole complex design? In the scenario, assertions will help. Assertion is a set of code, a set of lines that is written with every line that will help you to find out where could be the error. For example, now say this is your input and this is your expected output, and then let us suppose you are getting some fault at somewhere at any level of the circuit. This is your DUT, and if you have inserted the assertions properly, then you can have the information that these stars are representing assertion checkers. Then it is becomes easier that at which block of your code there could be the possibility reason of the unexpected output. So in this way assertions works. We will discuss this topic later on in detail. So this is all about the layered test bench, and this is all come under the environment block, that you keep on regenerating the environment depending upon the number of tests are going to be created by the program block. This is all about the layer test bench. Now let us move our basic steps, that are data types.